chemistry is all about chemical reactions and equations. Now, for writing chemical equations and balancing them, the most important thing that we must know is chemical formulae. It is the most important part of the language of chemistry. Hello everyone, welcome to my channel Pragya's Gurukul. Today we will learn how to write chemical formulae of different compounds like simple covalent compounds, simple ionic compounds with polyatomic ions. So let's begin. Chemical substances and compounds have become an essential part of our day-to-day life. The food we eat, the water we drink, the air we breathe, the substances present in our kitchen, bathroom, medicine cabinet are all made up of chemical compounds. As we all know, a compound is made up of two or more elements in definite proportions. Now, to figure out at what proportion and how the atoms are arranged in a compound, we need to know its chemical formula. So, what is a chemical formula? It is the symbolic representation of a particular compound that gives us the exact number of different atoms present in it. It contains the symbols of the atoms as well as how many atoms for each element are present in the form of subscript. Let us explain with an example. Sugar. Its chemical name is sucrose and its chemical formula is C12H22O11. It means the number of carbon atoms is 12, hydrogen 22 and oxygen 11 in the sucrose molecule. Again, the ratio between carbon, hydrogen and oxygen can also be found. It is 12:22:11. Remember one thing. For writing chemical formula, you must remember the symbols of the atoms of at least first 20 elements in the periodic table with their valencies. You also have to remember the symbols of ions, that is cations and anions. As you all know, ions can either be monovalent, divalent, trivalent, etc. There are polyatomic ions also. Poly means more than one. So the ions which are formed by more than one atom are called polyatomic ions. Now we are good to go for writing chemical formula. The method is crisscross or crossover. Let's start with simple molecular or covalent compounds. For this kind of compounds, the constituent particles are neutral atoms. Okay, these are the different steps to write chemical formulae. Number one, first we need to write the symbols of the atoms. Next, the valencies are placed below the respective atoms. For example, if we take carbon dioxide, the symbol for carbon is C, oxygen is O. Valency of carbon 4, oxygen 2. Now, number 3 step is valencies are shifted crosswise to the right of the atoms as subscript. That means the valency of oxygen will be the subscript of carbon like this, and valency of carbon will be the subscript of oxygen like this. So this should be the chemical formula of carbon dioxide. But according to the fourth step, we need to reduce the ratio between the atoms to the lowest one. That means we can lower the ratio of 2:4 to 1:2. That means there is one carbon atom and two oxygen atoms present in carbon dioxide. So now we will expect that C1O2 will be the chemical formula of carbon dioxide. But again, according to this rule, if the subscript is 1, it is not written. So we will not write 1 here. So what will be the actual formula of carbon dioxide? CO2. Similarly, in methane, we know that carbon and hydrogen are present. Valency of carbon 4, hydrogen 1, and therefore the formula will be C1, we will not write, and H4. Similarly, for water, hydrogen and oxygen are present. Valencies are 1 and 2 respectively, and therefore the formula is H2O1. We will not write the O. Moving on to simple ionic compounds. For this, we know that these are made up of cations and anions. Cations are mostly formed by metals and anions are mostly formed by non-metals. Here also, first we need to write the symbols of cations and anions, and then we need to write the respective charges below them. Let me give the example of aluminium oxide. Here aluminium is present, Al, and oxygen is present, O. The charge on aluminium is +3 and that of oxygen is +2. Now, according to the third step, only the number of the negative charge becomes the subscript of the cation. Here aluminium is the cation, so number of the negative charge, that means this 2 will be the subscript of aluminium, and vice versa. That means the number of aluminium, the valency of aluminium will be the subscript of oxygen. So what will be the formula of aluminium oxide? Al2O3. Similarly, ferric chloride. Iron can exist in two different valency form, either in Fe2 plus form or Fe3 plus form. Here it is mentioned as ferric. That means here iron is present in +3 state and chlorine -1. So what will be the formula of ferric chloride? Fe1, we will not write that, and NCl3. Done? Okay. Now here one very important point is the net charge of the molecule must be equal to 0. Okay. Let me check here. For each aluminium, total charge is what? 3. There are 2 such aluminium atoms. So what is the total positive charge? +6. For oxygen, each oxygen carries -2 charge. There are total 3 oxygen atoms. So total charge is what? -6. +6 -6 cancels each other, and therefore the net charge is what? 0. Okay. And we will not write this positive and negative sign here. Why? Because these represents number of the atoms, and number can never be negative, isn't it? Okay. Next comes ionic compounds with polyatomic ions. Mostly polyatomic ions are anions. Okay. Exception is ammonium ion, NH4+, though it is polyatomic, it is a cation. This is the exception, but other than that, most of the anions are polyatomic ions. Okay. Now, polyatomic ions are written within parenthesis or bracket before writing the number. Let me give the example of copper nitrate, copper 2 nitrate. As we all know, copper can exist either as Cu+ or Cu2+. Since here it is mentioned as Cu2, so the charge on copper will be +2. Nitrate NO3 -1. So what will be the formula? Cu1, we will not write the 1, and NO3 2. If we write 2 like this, then it will be meaningless, isn't it? That's why we need to write the parenthesis or bracket, so that it implies that there are 2 nitrate ions present in copper nitrate and 1 cupric ion present in it. Got my point? Okay. Moving on to magnesium carbonate. Magnesium Mg carbonate CO3. Charges +2, then -2. We can write Mg2CO3 whole 2, but again the ratio becomes what? 2:2. It is not the simplest ratio. The simplest ratio will be 1:1. So what will be the exact formula of magnesium carbonate? MgCO.
Hope this video is helpful for you. Don't forget to subscribe to my channel and press the bell icon for further notification. Thank you.